this video we learn to begin graphing lines, and there will be a shortcut method that we learn later on in another video, but this is an essential video. The first thing I want to emphasize is that a line is not just a solid object. A line is technically, in mathematical terms, an infinite collection of dots that are so close together that they appear to be a line. Now, with that idea, we start with this type of question asking, is this point on this line? When you are given a point, it's of the form x comma y, and we're basically asking you to substitute those values in and test whether 6 times 3 plus 5 times negative 4 is that question mark over my equal sign equal to negative 2. And in this case we have 18 minus 20, which is negative 2, which is equal to negative 2, and so the answer is yes, this point is on the line. Now that may seem like kind of a cheesy little way to start this whole section out, but quite honestly that is probably the most important skill in this chapter, because if you ever want to know whether you have graphed a line correctly, you want to take points that you have graphed on the line and verify that indeed are they on that do they work in the equation of that line. Okay, let's move on to our first actual graphing of a line problem. Notice it's of the form y equals. I like to describe this as, or this equation as, a rule describing the relationship between x and y. In this case, if we start with x, we're going to say add 5 to x, and that will give you what the y value is. Now we're going to create what's called an xy chart, and I'm going to insert numbers such as 0, 1, and 2 as input values. You can think of your x column as in values and your y column as output values. Later on in your next course we will change the words in and out to domain and range. Okay, for each of these x values we're going to add 5, and we'll have 0, 5, 1 plus 5 is 6, 2 plus 5 is 7, and each of these three can be considered a pairing or a coordinate point. And we would have 0, 5 right here, 5 units above the origin, 1, 6 right there, and 2, 7 slightly off my grid, and those would all be 3 points that are on this line that satisfy the line's equation. At which point we're now going to play connect the dots, and we put arrows at the end saying this pattern continues. Now usually in class I ask people how many points are on this line, and I usually get the answer 3. And the true answer is 3 have been identified, but technically there's an infinite number of points on this line. You can identify 1/2, 5.5, 0.8, 5.8, etc. There's an infinite number of points on this line. Okay, let's do this again with another equation. We look at the formula, we look at that equation, we say, okay, what is my rule? What do I do to the x to turn it into a y? Well, order of operations says the first thing we would do to x is multiply it by negative 1. So I'll write multiply negative 1, and then we would add 2. So 2 steps for each x value to become a y value. So here we go with my xy chart, and I'm going to choose 0, 1, and 2 as my input values. They don't need to be 0, 1, and 2. I mean, you could choose 15, 18, and 3000, but you don't want to plot 15 comma something or 3000 comma something. You want to keep these numbers close to the center of your graph, and you'd rather insert positive numbers instead of negative numbers, so there's one less thing to worry about. So here we go. Let's take 0, multiply it by negative 1. 0 times negative 1 is still 0. Adding 2, we get 2. We take 1, multiply it by negative 1, we get negative 1. Add 2, we get 1. Then finally, 2 times negative 1 is negative 2, plus this 2 makes 0. We would then have 3 points, 0, 2, 1, 1, and 2, 0, through which we could then draw our line. I'm going to again extend it outward further, and hopefully your lines are better than mine. And again, I'm going to draw arrows at the ends of my line. Now, you may look at this and go, okay, why do I have to plot 3 points? The answer is you don't. 2 points is sufficient because through any 2 points there is one unique line. However, we like to plot this third point for accuracy. If we make a mistake with 1 point, we'll know that there's a mistake when we kind of see that third point not lining up properly. Okay, let's continue on with yet another problem. Practice is really important in this section. Here we go with our equation, y equals 2x plus 1. The rule here is going to be take our x, multiply it by 2 for starts, and then add 1. And so let's use these same easy inputs of 0, 1, and 2. 0, when we multiply it by 2, we get 0. We add 1 to get 1. 1 multiplied by 2 is 2. Adding 1, we get 3. 2 multiplied by 2 is 4. We add 1 and we get 5. So here we go. Our 3 points are 0, 1, 1 unit above the origin, 1, 3, which is over 1 and up 3, 2, 5, which is over 2 and up 5. And through that we have our 3 points ready to graph. Arrows at the end saying this pattern continues.